Day 185 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. We're still going strong, y'all. We're getting started on the top 150 interview questions. Today is the second day of that. We're going to do all of them, so get excited about that. There's some we've already done, so we should be done before 150 days, but we're going to finish up the ones that we haven't seen yet so we could be more prepared as we continue down our LeetCode journey and start getting these interviews that we're looking for. But before we get started today, y'all, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow. And one way we can do that is to share this content out with as many people as we can find that will watch it, y'all. So your support is appreciated when it comes to that, y'all. Now, let's get into the question, and today we have question number 80. Remove duplicates from sorted array 2. The difficulty level is medium, but don't let that deter you, y'all. We're going to keep the solution as simple and easy to understand as well, because we're all here to learn something, and if you don't understand the solution, then you probably didn't learn anything, y'all. That's not what we want. That's not what this channel is about. So in order to understand the solution, first thing we need to do is understand the question. So let's get into it. Question says, let's see, it says, excuse me, y'all, mouse going slow. Question says, given an integer array num sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of num should hold the final result. It does not matter what you leave behind the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1, big O of 1 extra memory. Let's see what the custom judge says. It says the judge will test your solution with the following code. So, I mean, we don't really need to, I don't know what this is talking about, but this is how I guess they're going to judge the expected answer. We don't have to worry about that. It says if all assertions pass, then your solution will be accepted. So let's look at example 1 so we can make it make sense. In example 1, we have nums equals an array of integers 1, 1, 1, 2, 2, and 3, right? The output is 5, and nums is 1, 1, 2, 2, and 3 with a, with the underscore at the end, right? So, the input has 3 ones. It should be 1, 1, 1, 2, 2, and 3. The output has 2 ones, 1, 1, 2, 2, and 3, and the underscore. Why? Because it says remove the duplicates in place such that each unique element appears at most twice. So, in example 1, the input nums has 3 ones, but we are removing the duplicates so they only appear at most twice. That's why here they only have 2 ones, and we have an underscore at the end for the extra 1 that we had to remove, right? And the output is 5 because in this array, nums array, after we removed the extra duplicates, or after we remove the 1 so that there's only 2 ones, then the output is there are 5 elements, right? There's 1, 2, 3, 4, 5. That's why the output is 5. Or in this example, k equals 5. Let's look at the explanation too to see what it has to say. It says the explanation says your function should return k equals 5 with the first 5 elements of nums being 1, 1, 2, 2, and 3 respectively. It does not matter what you leave beyond the return k, hence they are underscores. So we're removing any element that appears more than 2 times, and then we're returning the count, what the count would be after we remove that element, which in this case would be 5, and we're placing an underscore at the end to keep that space that the element was in, right? So let's look at example 2 where it has a little bit more integers where we could explain it and go a little deeper into the explanation, right? So in example 2, we have input nums equals an array of integers 0, 0, 1, 1, 1, 1, 2, 3, 3, right? The output is 7 and nums is 0, 0, 1, 1, 2, 3, 3, and 2 underscores this time. And the explanation says your function should return k equals 7 with the first 7 elements being 0, 0, 1, 1, 2, 3, and 3 respectively. It does not matter what you leave beyond the return k, hence they are underscores. So let's break this down. Let's look at example 2. In example 2, we have 2 zeros, so we could put those there. Boom. We have 1, 2, 3, 4 ones. So that means we have to remove 2 ones because it should be, remember, at most, remove some duplicates in place such that each unique element appears at most twice. So in this case, originally 1 appears 4 times, but we only want it to appear at most twice. So we have to remove 2 ones. That's why there's only 2 ones here and 2 underscores over here, right? Then there's only 1, 2, we don't have to remove anything, and there's only 2, 3, so we don't have to remove. We could keep both the 3s, but we had to remove 2 1s, which is why we removed those 2 1s, and we just put 2 underscores at the end to keep track of the space or the memory where those 1s were. However, we have to return k, and k equals 7, so we have to return the number of elements that are left after we remove those 2 1s, right? And in this case, it's 1, 2, 3, 4, 5, 6, 7. We're not counting the underscores because they're technically removed. We're just saving the space. So there are 7 elements left after we remove those 2 1s, and that's why the output is 7. That's why k equals 7, right? So now that we understand the code, let's get into the fun part, the part we all know and love, the code, right? So, now that we understand the question, let's get into the part we all know and love, the actual code. And it's not that long, y'all. It's not that difficult to understand either. Right, so let's get into it. First thing we're going to do, we're going to declare a variable. We're going to call that has duplicate. So we're going to check to see. We're going to set that equal to false. So we're going to check to see if we have already seen a duplicate. That's going to let us know if we've seen a duplicate or not. Then we're going to declare another variable called I. We're going to set that equal to 0 because we'll be starting at index 0. Then we're going to say for j n 1 up to nums and dot count. What we are going to do is we're going to say if nums j equals 2 equal signs nums I and exclamation point has duplicate. So and does not have a duplicate. That's what that exclamation point means. We're going to say has duplicate. We're going to set that equal to true. So if nums j is equal to nums I and it doesn't have a duplicate already, then now we know we have a duplicate because nums j equals nums I. So we're going to set has duplicate to true for those two, for nums j equal to num I. And then we're going to increment I by plus equals 1. So we're going to increment I by 1. Then we're going to set nums I. We're going to set that equal, whoa, my bad, y'all. Nums I, we're going to set that equal to nums j. Then we're going to say, come down here, we're going to say else if nums j does not equal nums I, so exclamation point equal nums I, then what we are going to do is we are going to say has duplicate equals false, and we're going to, that should say false, not flash. Then we're going to say, come down here, we're going to say I plus equals 1. We're going to come down here, we're going to do the same thing, nums I equals nums j. Then we're going to come down here and we are just going to say return I plus 1. So let's see what happens with that. Let's run it. Make sure it runs how it's supposed to. Make sure it runs properly. And it's accepted, y'all. So let's submit it. Drum roll, please. 16 milliseconds. Excuse me, y'all. I don't know why that keeps popping up. 16 milliseconds beats 25.93% of users with Swift, y'all. Those numbers could be better, but don't worry, y'all. This is a solution that anybody could understand, especially beginners. I'm a beginner myself, so we're all trying to learn here. We're not trying to take any extra steps that we don't need to take. We're just trying to make sure we understand what we're coding. We're not trying to get fancy on any of that stuff. We're just trying to understand what the solution is and how the solution works. And I feel like this is a good solution for that, for no matter where you are on your coding journey, y'all. So don't worry, the numbers will get better as we get better. But right now, we're just trying to get these questions understood and done. So that's all we have for today. I hope y'all learned something. Get one more look at the code, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.